Well, welcome to Emerald Hill Skies. My name is Doug. We're located on the outskirts of Louisville, Kentucky, and we're here tonight in what I think might be 17-degree weather. Let's go over and check our temperature out on the telescope. Yep, 17.8 degrees. Brrr. I tell you what, when I came in from setting up, my fingers were so cold I couldn't feel them. But I guess the advantage of that is that when you come in from the outside, you feel so good because you get warm again, and that's exciting. I just am happy that you're here tonight. I know that you have a lot of things to do. This is Winter Olympics, and I was thinking you could go ahead and put them on if you wanted on the TV so you can kind of watch them out of the corner of your eye if you like. That's one idea. I also know that today's been a game filled with lots of basketball, and maybe you're a basketball fan. For whatever reason, though, you decided to take part in this. On a clear night, you can see forever. And I don't know if you can see what we're seeing here, but this is the double cluster, otherwise known as NGC 884. And according to my log here, the last time I looked at this was January 29th. So that's just over a year ago. And it's about time we get back to the double cluster. Melissa Payton, welcome. My goodness, what a great surprise. I bet you've got 12 inches of snow up there in northeastern Ohio. I'm going to associate this with an observing list, and the observing list we're working on is the Herschel 400. And I've never done this catalog before. I think it has a lot to offer. 400 objects, 400 targets, and it scatters across all 4 seasons. So I'm looking forward to being able to do that. Let's do a new log entry for tonight. And let's say the double cluster was crystal. The double cluster was crystal clear. And the cool thing about the double cluster is that instead of just one cluster, you get to see 2 clusters. So you see this concentration of stars here, and then another concentration of stars here. And this is in the constellation Perseus, and it's one of the night sky's finest jewels. NGC 869 and NGC 884. It's a pair of bright, large, open clusters, and they're embedded in the faint glow of the Milky Way. It's visible without optical aid, but binoculars are required to separate the 2 clusters. And you can see our RASA 11-inch scope is doing that just fine. Let me make sure you're seeing what we're seeing. Yeah, our RASA telescope, 11 inches, is separating those just fine. They're half a degree apart, and it says a rich field telescope, which I guess that would be the RASA would be one of those. Classified gives the best view of the double cluster with many stars of differing brightnesses visible. NGC 869, and that's this one, is more tightly packed than NGC 884 here. Both clusters are about 7,000 light years away and are part of the Perseus arm of the Milky Way galaxy, one of the spiral arms of our Milky Way. 2 clusters are a few hundred light years apart. So imagine if you were, let me just zoom in a little bit. There we go. Imagine if you were a planet of, one of these stars here. Of a night, you might see the double cluster, the cluster of NGC 884. And then of a daytime, you might see bright stars from NGC 869 popping through the sky. This is a live view that you're looking at. This is not some kind of planetarium software. It's a live view. And these exposures are just 4-second exposures. That lets you know how bright these clusters are. We do have the gain turned up pretty high on our ZWO ASI2600 camera out there on the RASA. Are you able to see the RASA? Yeah, you're able to see the RASA down there in the lower right-hand corner of your screen. And we've got the gain turned up pretty high, but nevertheless, this is a real time view, and these are not images that have been stacked one on top of the other. These are just 4-second snapshots. So that's the double cluster. We've logged an observation, and how about that? Only 399 objects to go. Now, we're not going to get through all these tonight. This is a long-term project, but we're happy that you're here with us to see the start of it. And if you're watching this recording if you're watching this video as a recording, then welcome and delayed viewing. We're still happy you're here. All right, let's go on to the next one. And at 44 degrees above the horizon is NGC 891. So let's slew there. And while that's slewing, let's go over to the camera that rides on top of the telescope, but it's not looking through the telescope. And that's this one. This is a ZWO ASI2600MC monochrome camera. And we have it running at 1 second exposures, and the gain turned up really high. It's a monochrome. It's a little bit more sensitive. So you can see it's kind of looking at the whole night sky. I don't know if you can see up here on the top. There are the 3 belt stars of Orion, for example. And so we're going to look right here. Let's go over to the planetarium software, and let's center on NGC 891. And we'll go ahead and check him off there. And you can see that crosshair. That's a sign that our telescope has already arrived there. And let's zero in. Wow, that's a nice galaxy, isn't it? So this outer red rectangle you see is the field of view of our RASA telescope. And I'm just looking here to see, looks like we'll get a nice couple of stars, little bright stars here. Might pick up another couple of other galaxies. We'll just open up that info window and pull it over here. Now let's go back over to the live view. And since we did slew to a different part of the night sky, and this is just our second target, why don't we do another plate solve since we're still getting used to this particular model of the night sky. We had to set up from scratch tonight. We don't have an observatory going yet. So what this does is compares the view through the telescope live with, and it was about 0.06 degrees off. That's only a 600th of a degree. Hardly worth correcting, but it does make the rest of the night more accurate. So we'll go ahead and maybe read just a little bit about 891. It's a spiral galaxy in Andromeda. Oh, there goes is that a satellite? Must be a satellite photobombing us. I can barely see a cloudy image there in the middle. What we're going to do now is change our exposure to more of a time exposure, and this will adjust our camera so it's giving 20-second exposures. And the gain that we use is pretty much the ideal gain for this camera. A lot of people would like to see us do a higher gain, but I like this gain of 100 with this camera because it results in a really low noise level, and we get a very high signal level, good high signal to noise level. We'll just do a color balance reset, kind of white balance, I guess you could call it. We'll bring the blacks down to that crest so we get the night sky, and then we'll start trying to push these mids up a little. And now we are live stacking, so this is our second frame. With our second frame, you can already see the galaxy forming up. We did autofocus before the broadcast began, and oftentimes we'll have to autofocus again after another, 20 minutes or so, because the telescope will continue to chill down to that 17 degrees. Let's go take a look at that temperature again. Yeah, it's dropping. Now it's down to 17.6. You might wonder how we get that accurate of a temperature. This is a special temperature gauge that's associated with the Pegasus Astro Pocket Power Box Micro, which is out there riding on top of the telescope. And that Pocket Power Box Micro has a very accurate thermometer on it, and it measures to the 10th of a degree. So 17.6 degrees Fahrenheit. I can see that up here. I don't know if you can read that fine print up here in the upper right of your screen. It also has calculated the dew point to be 15.6 degrees. And then what it's doing down here is it's activating the dew zapper strips, the dew heater strips, the bands around the RASA 11-inch telescope and also around the little ASI ZWO A178 camera. And by heating those cameras with pulses of heat now and then in those dew straps, the dew heater bands, it keeps the dew from forming on the front, the corrector plate of our RASA telescope and on the lens, Lord willing, of our little 178 all-sky camera. You can see we're pumping about 12.9 volts out there into the system, and that's about what you want, something above 12 volts. You don't want it to drop below 12, and that's bleeding about 2.6 or 2.7 amps, depending on which dew heater is lighting up. So we get really good reports from all of our Pegasus Pocket power box there. So I guess we might as well put that away. Probably don't need to look at that. We've got 8 frames coming in now, and that ghostly, let's see, I need to change this name here. Fortunately, with this version of SharpCap, I can do that on the fly. NGC 891. And do we want to save the new name? Yes. It's a spiral galaxy in Andromeda located 30 million light years from the sun. This galaxy is large and ill-defined in a telescope and requires averted vision to be seen because of its low surface brightness. This galaxy resembles what our own galaxy, the Milky Way, would look like if we were viewed edge on. Now, I've never looked at this galaxy before. This is the first time for us to see NGC 891. We're going to zoom in just, well, that's about as far as we can zoom in. This is a pretty small target. And let's see if we can maybe darken the sky just a little bit. We're enjoying these darker and clearer skies. The moon is about to set, if it hasn't set already. So we're gonna color balance again. White balance, just again, a little bit too much blue still, huh? We'll just bring the blues down a little bit. Now you're starting to see it. Look at that. Now that black stripe that you see there, this almost reminds you of a racing stripe across the the spiral galaxy, doesn't it? That's a dust lane. It's basically a cloud of soot that's being thrown off by all of the churn of this galaxy. And as we view this, we're looking at the spiral galaxy edge on, and that dust lane, see, has been thrown out. It's more like soot probably than it is dust, like ashes from all the burning stars that are flinging out the dust. 30 million light years away. Think of that. What were you doing 30 million years ago? Well, whatever you were doing, that's when the light, the photons, started to make their journey our way. And isn't it amazing that they came across all that interstellar space and were never interrupted until they landed on the mirror of our 11-inch telescope out there in the field. And you are looking at a real-time view. This is not some kind of a software that gives you a planetarium view of this from a coffee table book. This is a real-time view of this galaxy. 17 frames, about 5 minutes. Again, this is the Herschel 400 list. We're going to log an entry here in our software, a new observation. We're going to say we could see the edge on galaxy and the thin dust lane like a hamburger in the middle of a couple of pressed buns. How about, let's say, how about that? NGC 891. And there you see the planetarium software view of it. And you can see that's almost exactly what we're seeing. These are nice. These are, I guess, probably little stars, little globular clusters and all that are being thrown around this galaxy. And I don't know if we can make those out because those are very tiny. Let's see if we can. Yeah, look at these little stars that are either in the way, on the way to the galaxy, or they're actually a part of the galaxy. That's really forming up nice. Look at the way you can see the yellows and the greens. Nice. Let's save a picture of this. And like I say, this will be the first time that we've ever captured an image of NGC 891. First for me, my first time to go through the Herschel 400, and I bet for you as well, maybe some of you have done it. We have several now watching the live stream. So let's go to the next target now, and that'll kind of get our camera ready. We'll back off to auto here, and let's go back over to our planetarium software, and we'll go to the next target, which is NGC 908. So why don't we back off a little bit so we can kind of see where we are in the sky. There was that double cluster we just saw. And this is, the tree line here at Emerald Hills. And this is a photorealistic horizon. In fact, I don't know if you can see down here at the bottom, that's one of the prayer shelters here at Emerald Hills. A little gazebo-like prayer shelter and a fence row there. This is a realistic view, and there's the Milky Way kind of coming up. And we're looking just above Andromeda. Here's the cone of Andromeda. And so we're looking right there. You can see we're about, 41 degrees up from the horizon. NGC 891 is where we've been. Now let's go to NGC 908. NGC 908. You can see the crosshairs of the scope there. And then in this view, you might be able to see the scope moving a little bit. There's a little bit bigger picture of the scope. Well, it's not wanting to cooperate. There you go. It might. You see a little bit bigger. Now, this is a night vision camera. It doesn't have infrared, by the way, but it is showing you the tripod. It's actually a tri-pier, and this is sitting on a concrete pad that's going to be our observatory. So this is the real site where the observatory will be located, and we're looking up just like you would sight down a rifle from the camera. And now the scope has slewed over to the west, so we're still looking up toward the North Star, and the scope has turned now. This little assembly you see here on top, that's that little ZWO ASI2600MC camera in front, and then the Pegasus power box and the Pegasus USB microcontroller there riding on top of an equipment plate. And that kind of gives you a good view of the way the scope is set up. Here's the black dew shield in front of the white telescope, and just really has one wire that has to hang down with the way the scope is set up. Everything is hooked into a USB hub on top of the scope, and we only have to run one data cable down, and that kind of makes it a lot easier on the telescope. We run a little tiny power cable up to that USB hub up there as well. The Pegasus power box micro up there does some distribution, but you can see our neighbors' trees here. I don't know the way they have their lights set up. They're kind of backlighting those trees in a big way, aren't they? But I don't think they'll get in our way doing electronically-assisted astronomy like we are. Let me size this back down so it'll be back out of the way. We'll put it approximately where it was, kind of over here again out of the way. And let's go over to our, we're getting down in the trees, aren't we? Wow, that's sad. NGC 891, how tall are you? Oh, 908, NGC 908. It's just 5 degrees above the horizon. That's why. As you can see from our planetarium software here, let's center on NGC 908, and boy, we don't have our trees dialed up high enough, do we? This photorealistic horizon's kind of letting us down. NGC 908. I think this is a bit of a distortion. Watch as we zero in. Let's zero in on this, and you'll see that target head down into those trees. Yeah, those are the trees that we're looking at. So this target is about 5 degrees above the horizon. Those trees are roughly 10. So this is going to be too low for us. So we won't be able to see this one tonight. We'll have to catch that on another night. How about NGC 936? Can we catch that? Let's see where that is. Yeah, that's over the light dome of Louisville, but we ought to be able to get to that. Let's slew to that instead. That was funny, wasn't it? We looked at that view through the telescope, and there were those nice tree limbs. Wow, Dennis Luttrell, Snowy, Colorado. How many inches do you have out there, Dennis? I'm going to guess you've got at least a dozen, but now maybe some of them melt away today. This is NGC 936, right? NGC 936. NGC 936. Let's open up our information about that. Again, we're doing the Herschel 400 list. Now, I've never done this before, but I'm looking forward to it. This is a barred lenticular galaxy in Cetus, about 60 million light years away. So let's kind of zero in a little bit more and see what we should see. See how lenticular galaxies are kind of like little blobs. There's not a lot to them. Let's go over to SharpCap, and let's change the name here to NGC 936. And let's start our live stack. So we're going to start imaging, and 12 inches right on the button. Man, that's enough to run a snowmobile. Dennis, do you have a snowmobile? That would be a lot of fun. Okay, I think we cleared it as a part of our sequence. I did check on that today. And we're going to do another color balance on this part of the sky because it is kind of there in the light dome of Louisville. And we'll pull our mids up now and pull our black level up. If you were with us a couple of weeks ago, you might recall I was trying to clean my mouse right before the live stream started on my trackpad. And that was a dumb idea, trying to use some hand sanitizer to clean my trackpad. And lo and behold, after cleaning it, it wouldn't work. So it really woke me up to try to maybe get a mouse. I don't know if you can see this mouse here, but I'm really enjoying this. I've never used a mouse before, but I'm kind of happy to be using it because it is a lot easier to do certain things like drag these bars. I'm finding it a lot more exacting to have a real live mouse. Now I'm not seeing this object. I wonder if we should have played solid first to make sure it's right in the middle of our frame, because I'm not seeing it. Are you? Let's stop live stacking for a second. Let's put us back on a faster gain and a shorter exposure, and let's do a plate solve here, and make sure that we have this object centered. A barred lenticular galaxy shows a bright condensed core in a telescope. Okay, so it's going to try to plate solve here. Yeah, it was off about 0.17 degrees. So I'm glad we plate solved. This will put that object right in the center, so we'll know where to look for it. No snowmobile, but you do have a snow blower. Well, I suppose when it comes time to shovel, that's probably a little more fun anyway, isn't it? Okay, now that we're back, let's start our imaging over again. And notice that I did check our sequence, and it does clear the live stack. It resets the live stack. So I don't think we have to clear it. Are you guys hearing my audio okay? One listener to the recorded version told me this past week that my voice sounded too low. And so if you guys don't mind telling me if I need to turn it up a little bit, I can. But hopefully you're able to hear this audio okay. And maybe you're kind of glad you don't have to listen to my voice all the time if it's too low. Oh, see, there it is. Let's see if we can't get rid of some of this noise. You see how the image is real grainy? It's got all that dust in it. Like, it's not dust, it's actually light noise that's produced by the city of Louisville. Just to get a picture, let's go over here to our ASI ZWO 178 and look at this light dome of Louisville here. That's a real-time view. That's real light, and that's just the city of Louisville. By the way, in this picture, if you turn your head kind of to the side and look very closely, you can see my truck parked here on the service road. Now, it's shorter than these trees. I've checked that before to make sure that I'm not blocking the view. The truck fits under the trees, and you can't really see it very well, but we're sitting on a concrete pad. Actually, if you look very closely, wonder if I can dial this up. Let's make this 3 seconds. See if we can brighten up that landscape a little. Yeah, almost makes it look like daylight, doesn't it? See that little thing sticking up there? That's the conduit. That's where the cables are going to go in the side of the concrete pad, and then go under the concrete so we don't trip over them. How about that? And see how there's an edge here? That's the front porch of the observatory. So you're actually sitting on top the concrete pad of the observatory. And there's the truck where I unloaded everything. Man, I cannot wait to have an observatory so I don't have to set everything up every single night. Oh my goodness, that gets old. Let's go back to SharpCap and take a look at what's happening here. There's that barred lenticular galaxy. Boy, it's just not very photogenic for us, is it? Let's see if we can help it just a little bit. I'm going to hold my shift key down as I pull this bar over, and that'll let me make smaller changes. Man, I don't know. Let's add just a little bit of blue. Too much. Hold the shift key down. That's probably about all we're going to get. Okay, Melissa, thank you. Melissa says that there's not too much bass turned up in the mic. So Dennis, does sound okay here, but in the past it was a little... Okay, well, that's helpful. Dennis, thanks. Hopefully this has fixed it. Well, that's the best we're going to see. We would need a different telescope, I guess, to make more out of this little tiny galaxy here. That's the best we're going to see. So let's save that as seen. It's just a little glob in the sky. But if you go back over to our planetarium software, see, that's actually what it looks like, isn't it? It just looks like a little blob there, doesn't it? That's really all it is, just that little blob. And so we're going to say, add a log entry. we could see the little blob, but honestly, that was about it. Very tiny in our wide field RASA. The RASA does have a wide view. It's like a couple of degrees wide field of view, so that's hurting us a bit. So I guess we've already saved a picture of this, haven't we? We did, such as it is. NGC 936. Okay, and then we already did the double cluster too. We didn't do NGC 908. Looks like NGC 1022 is about 16 degrees. That's pretty low, isn't it? But let's give it a try. Let's go to our sequencer and go to next target. And what that'll do is dial everything back up, make the sky bright, and let's change our title while I'm thinking of it to NGC 1022, not M as in Mike, N as in Nancy, NGC 1022. So that'll be done. And back over here on our planetarium software, what we do is we click that, and then we issue a command to slew to it. And slew is just a fancy word for move the telescope. And this is where we can go over here and we can see if it moves any, we can see it moving in this monochrome. And then here we can see, if you look in your lower right hand corner, you can see a view of the telescope still pointing west. And let's go back out to full frame. And I don't think we had to travel very far, did we? So let's go ahead and start our live stack and then read something about this. Start imaging 1022. It says it's a spiral galaxy. Oh, no facts about it at all. That's a bad sign. Let's center it and kind of zero in on it a little bit and see what it looks like in our planetarium software. Oh my goodness. This thing is so small, it's not even imaged in our planetarium software. Doesn't even have an image of it. Look at that. And our planetarium software has images of a lot of things. This is Starry Night Pro Plus. It has 20,000 pictures of the night sky. If there's no image of this galaxy, it must be very, very faint or very small. Let's look here in the general info. It says it's 12th magnitude. That's at the limit. And let's see if we can tell how wide it is. 2.6 minutes, 2.6 arc minutes. Well, let's give it a try. Here we are back over in SharpCap. Uh-oh, we're down in the trees. Can you see them? These are the images of the trees. So let's go back over to our planetarium software and look at where we're imaging. Yeah, I need to make those trees a little bit taller because in this case, let's see, we're at 15 degrees and that's where the trees are. Can you see them? They're just right here. These are where the trees are. So I think that's the galaxy right there. Let's try it and just see there on the edge of the trees if we're able to make it out. Let's zoom in at 100% because it is very small. Oh, look. You can see just the slightest little glob of fuzzy right there on the tops of the trees, can't you? I tell you what, we need to get used to capturing these tough targets because Messier Marathon's coming up. What is that? In March, right? And so we're just about a month away. And some of these targets they dive down on that horizon, and we got to be ready for them. Well, that's a shame because I think if there weren't those tree limbs there, we would do a better job collecting this data, I think we'd see a little bit more than what we're seeing. Tell you what, in our planetarium software, right here, I'm thinking we're going to have to dial these trees up a little more. I'm trying to get this horizon set so that it matches the reality. And you can see I'm still probably a little off. Let's look at our view and see if we can find these two stars, see if they're down in the trees yet. So this is the real-time view. Let's back off a little bit, maybe 50%. Oh yeah, look, there are these two stars. See how that makes a little triangle? Let's go back over in our planetarium software. And can't tell which two stars we might be seeing. Maybe these, you think? Either way, we are seeing them there. Let's see what other image we can see. Here's, look at how this triangle, wow, that galaxy's starting to come in, isn't it? I wonder if that's just the light dome of Louisville. Might be just the fact that we're lost in that light dome of Louisville. Yeah, I bet that's it. Thanks to all of you all for tuning in. If you haven't yet told us where you're viewing from, please do that. It looks like we've got several there listening. We're working through the Herschel 400 list, and this object is very difficult because it's right near the horizon. Let's get the exact height again. Is it 15 degrees? Why is it not coming up with our little... There we go. That's 13. So this is probably... Indeed, just a little bit less than 15 degrees. So this entire part of the night sky, you know, I have a I have a thing made. Let me show you. I did this the other night just for fun. Let's search for the word light. Light. No. Let's search for options then. Options. And then a local view maybe. Here, local light pollution. Distant light pollution. There. See how that started flooding it a little bit. I actually need to turn it up a little more, don't I? Distant. Brightness. There. More like that. There we go. Now, I don't keep that turned on all the time because look how ugly that is. But that's really what we're seeing. Let's go back over to our live view. Let's see, we'll move this back over here so it's out of the way for a second. And go back over to our live view. All of this view down here is light pollution. Sad, huh? Scott Visions, Niagara Falls, Canada. Man, glad to have you aboard. I bet it's cold in Niagara Falls this time of year. Look at this. We're starting to see a little bit more of this galaxy now. Look at that. It just says Spiral Galaxy, NGC 1022. No other data about it except it's 2.6 arc minutes wide. We could make out the fuzzy patch, very tiny in our 11-inch RASA, but visible. Tell you what, let's do. Let's, since we don't have a picture in our planetarium software, let's go out for a second to the web and let's go to NGC 1022 and yeah, look at that. It's a very small spiral, but look how you can start to see. Let me see if I can find some bigger images here. Look at this. You can't really make out too much dust lane there, can you? That's that's Hubble. That's the Hubble Space Telescope. So in a typical amateur scope, you know, this is an 11-inch amateur scope. Look how these are showing it as a very small. Now there's a little bit larger, but can't see much detail there. Just still not able to pick out much except for just a tiny grainy view of the outer spiral arm. So this is definitely looking from the top down, and this is 10 arc seconds. This is from the Carnegie Irvine Galaxy Survey. So this is an observatory view. So I don't feel too bad that this is all we're able to see. Dennis says, wow, Scott, I think I'll keep what I have. By Wednesday, it'll be gone here. Minus 16 centigrade. Yikes, minus 16 centigrade. Let me think. 16, so that'll be about 30. So that's 0. You're at 0 Fahrenheit. Scott says 32 inches of snow in the last 2 weeks. Boy, I bet Niagara Falls is beautiful with all that snow, though. Anyway, if you look very closely, you know what we're going to do? We're going to break the rules. We're going to go up to like 300%. Look how we can just barely start to see some of the spiral structure. No, that's mostly my imagination, isn't it? We've got the camera turned up at 300% of its capability. Having looked at those pictures, though, we can see a little more of the spiral structure if we squint. Oh well. Let's do save an image just so we can say we did. You know, another thing we have to realize is how low this is to the horizon. Remember, we're at 12 degrees. Wow. And we're in the light dome part of the sky. So not bad. Let's turn off that light pollution because I don't really get a big kick out of it being on, because it just kind of reminds me of something depressing to have that light pollution. Now let's go back to lists and open up our Herschel again. And we were at 1022. Let's see if it saved our check marks. I'm always curious if it's going to save check marks. What it's doing here is calculating which of these objects are visible right now and which are positioned in such a way that we can see them. It didn't save the past ones. That's okay. We're working our way down. Let's call it a day on NGC 1022. We already did an observation there, and let's turn off our live stacking here. And I think if we just go to the sequencer and go to the next target, I think it stops it for us. Yeah, it stops it. And let's, in our planetarium software, let's go to, let's see, we did 1022, right? Yeah. So we're ready for 1023. Now, interestingly, it is at 39 degrees. So there you see the crosshairs moving. And then here you can see the 178, the monochrome camera, which is not looking through the telescope. It's the one that's just looking at the sky. You can see it kind of spiraling. If you look closely on the monochrome camera, down here at the bottom, I'll dial up the light a little bit for you. I go the wrong way. Yeah. I'll dial up the light a little bit for you. To show you where you are, this is down here at the bottom. That's the edge, the outer length of the dew shield, you know. So that shows you where you're riding on that 178. And this is the light pollution of Louisville. So you can see what we were looking at. I'm going to dial this back down to 1 second, just again, so it doesn't remind me of all that light pollution quite so much. All right, let's go back over here. And I don't think we have to plate solve, but let's do it one more time just because we can. And what that'll do is make sure that our next object is right in the center. I think I see some kind of a fuzzy patch right there. So it is plate solving, and it found 1/10 of a degree correction. And every time we do a correction like this, it files that correction into the computer model that's in the mount, which is the part of the scope that holds, it's part of the tripod machine that holds the telescope and points it. And that computer keeps a record of all those corrections. And that way, we can sort of assemble a model of the night sky in such a way that we can point very accurately. That's what all those corrections do. Boy, we're glad you're with us tonight. As you can see, I'm trying to learn to move more quickly through different objects. This NGC 1023, let's go ahead and check that. Sits pretty low on the horizon too. Let's center to that. Oh, we are still at 1022. No, we're good now. We're up above the horizon now. And now let's show info. And let's also zero in on this, kind of zoom in on this a little bit. Look at that. This is an elliptical galaxy. It's a barred lenticular galaxy in Perseus, located 30 million light years from the sun. NGC 1023. It appears as a small, bright ellipse in amateur telescopes. Larger scopes may show an eastward extension, which is the galaxy NGC 1023A, which is being absorbed into NGC 1023. We're seeing a fight going on here between us. This galaxy is thought to have a massive black hole in its center. So let's close that word and let's see if we can make out 1023A. I don't guess it's pictured here, is it? Oh, here. This is 1023A. It says eastward extension, but to us, it looks north, I think, in the way our planetarium software is looking. So what we want to see is the core, and then one edge is going to be longer because this galaxy is a different galaxy being eaten up. It's being absorbed by the gravity of this huge black hole, sucking it in, you know. Okay. And it's at 38 degrees above the horizon, and we've never observed it before. It's only 7.4 arc minutes, so it's very small. We'll put this over here, and let's go back over to SharpCap now and see if we're going to be able to make anything out. Let's do a new color white balance because this is a different part of the sky, and we don't have to mess with as much of the Louisville light pollution now. And we do use a light pollution filter. It's the Celestron LP, the light pollution filter that they tune for the RASA. I think we're seeing, let's dial that blue down just a hair. I think we're seeing that galaxy in the middle. Can you make it out yet? Boy, it's tiny, isn't it? Now, I think I'm going to hold the shift key down, and that lets me do a too much blue. I thought it let me do a finer. Wonder if I can just touch. Yeah. I'm touching on the blue instead of sliding with it. My friend Rol from Belgium told me sometimes you should just touch on the blue. Okay, let's go into 100% zoom now. Yes, this is NGC 1023. And now the question is, are we going to be able to see which side? Are we going to be able to make out which side has the 1023A? It should probably be on top. Look at these stars all in a row here. One and then two smaller ones. 1, 2, 3, 4 stars in a row. These 3 stars are on the left. So let's go back to our planetarium software now. Hello. Yeah, there they are. Look, these 4 stars in a row. Yeah, and then here are those 3 in a row. So see where these 4 stars are in a row? The last star. And what we can do, by the way, is we can tell the name of that star. Nope. It's just a picture of it in the Starry Night Pro Plus. This is what we get with the Plus, is these pictures of these dimmer stars, but they're not actually named. These 3 are. This is USNO and then that long number, but this one is not named. But look at that galaxy there. Isn't that fun? The way you're seeing the tidal forces eat this up. Let's go back over to SharpCap, and let's hope that before it's over, we can start to see that this side is a little bit longer. Let's go at 200%. It's going to be beyond the pixels of our camera, but see, up here is where we should start seeing some dust form. And we're going to continue to push our mids up to try to help us see that. I'm going to go out. Let's go out here and let's see if there's any good view of it. Not really that much better than what we have, is it? Now there's a fuzzy patch out there. Look at that. You can see that fuzzy patch there. That's all there is to it. Not much. There's not much out here by these stars, but this is that smaller star that we didn't have named on our planetarium software. So it's in between it and the galaxy. So let's go back to our live view. I keep forgetting I can zoom into this picture with my mouse now. That's really nice, isn't it? I've always used this drop down before, like that, but now we can zoom in and out, or we have to hold the control key down to zoom in. And then when you do this, it moves it up and down. Isn't that something? So right here, if you look closely, we're starting to see a little bit of extra, I would just call it nebulosity. We're at 125%, so you can see a little bit of pixelation there. 7 minutes and 40 seconds. Boy, it's the limit. The limit of our Louisville light pollution. I bet if we were out at a dark sky site so that the light pollution wasn't lighting up the whole night. I think we might be able to make out more than that because we're just barely making it out. So let's go to our log entry here. And let's add. We were just beginning to make out the NGC 1023A bite size galaxy that is being consumed by the tidal forces of NGC 1023. However, we would need a bit more. They call that, like integration time, a bit more time on this object to live stack and see the companion 1023A. We need some more time on that. Integration time. But just barely can start to make it out up there. Some of our stars are just barely starting to show some out of focus, so we're going to have to focus soon, but it only shows up, boy, that's ugly. All that light pollution is ugly when you back off, isn't it? I am using what you call calibration frames. That's 9 minutes, 10 minutes actually. I'm using calibration frames. I'm using darks and flats, both. What those do is subtract pixels that are hot, at least most of them. That might be a new hot pixel there. Subtracts out the hot pixels, and the flats are supposed to get rid of things like this vignetting. But obviously it's, with the light pollution kind of showing it off, it's looking a little bit stretched there. So next target, and let's go back over here. So we're done with 1023. Let's back off, and 1027 is at 43, so let's go there. Slew to NGC 1027, and let's make sure that we look in the 178 so we can watch its slew. So that's pointing out, hey, there's Jeff. Welcome, Jeff. Boy, you tune in late. You are a night owl, Jeff. Jeff, we've got Scott on from up in Niagara Falls. His temperature is like zero, minus 16 degrees centigrade, like 0 Fahrenheit. And then down there below you, we've got Dennis. He has 12 inches of snow. Scott has had 30, how many was it? 32 inches in the last 2 weeks. And we have several others on the live stream. Welcome, everybody. Glad you're there. As I said earlier, we're working our way through the Herschel 400. And we've just gotten to NGC 1027. NGC 1027. And since we slewed, I know, we don't have to, but I do like to do these plate solves so that we make any corrections in the mount that we have to. And let's center and also show info. It's an open cluster. Oh wow, this is a beautiful part of the night sky. It did make a 0.07 degree correction. We won't have to live stack this. Look, we can already see this open cluster. It is also known as a galactic cluster. Boy, that sounds important, doesn't it? Wouldn't you love to be? Frank just got back from 85-degree Orlando. No way. Are you fibbing? Frank says, I need to move. Wow. Frank, we're working our way through the Herschel 400, just getting started in it tonight. Many open clusters have a relatively large angular size, so they're best viewed in binoculars or low-power telescope eyepieces. Some open clusters are visible to the naked eye, including the two most famous, the Pleiades and Hyades. This one has a size of 6 arc minutes, so it's not huge, is it? We're up about 40 degrees, and I'm just going to say here, nice salt and pepper open cluster, lots of pinpoint stars. We saw some blues and some whites. Nice cluster. Let's zero in and see what we see here in the Starry Night Pro Plus version. Look at this nebulosity here just off to our right. What is that? Is this the heart and soul thing? I think this must be the heart and soul deal. Yep. Dennis is already looking. Frank, we are jealous, Dennis says. Frank says 6 perfect days. Jeff, I can't win here in Montana, Frank. My Mounds RA froze last time I was out. That's horrible. Oh my goodness. You know, I have to keep heater tape on this little telescope, the scope view deal that we're seeing, right? Let's see if I can grab it. This scope view. I have to keep heater tape on this WISE cam because it freezes up and just stops working. And then what I do here, I put a blanket over the equipment rack that I have out there, the thing I called a rig rack. It's got the extender in it that lets me operate inside 200 feet away. And it also has some other equipment in there, the rig runner, power distribution, and it has a power supply in it, has I don't think the 12-volt power supply would ever freeze over, but nevertheless, I put a blanket over it because it is cold out there. Let's see what it is, 16.5 degrees Fahrenheit here. So I would say it's chilly for this part of the country for sure. If I can get that off to the side again. So we're looking at NGC 1027. Let's go back over one more time. And there's the cluster. While we're here, let's just see if we can pick up that heart and soul nebula deal. We'll take a little detour. I don't think we have to take a picture of this, but let's do it. Just take a snapshot. How about that? There we go. And then as far as this heart and soul, let's look at this. So IC1848. It's about the best I'm going to do. I wonder if I can just put the scope on this star. That's an ugly picture, isn't it? Frank, you were talking about this the other night. You were saying the picture in Starry Night Pro Plus for whatever this is. Is this the heart side or the soul side? Well, they don't say much about it, do they? I probably don't have the main name, do I? Is IC1848 the main name? Select other. Oh, that's a cluster. Diffuse nebula. Oh, IC1848, yeah. LBN 672, is that the... No. That's not it either. What's the catalog name of this object? Do we just call it the heart and soul? That's the soul, Dennis says. Okay, so let's try it where we are. Let's go back over here, and we're not going to plate solve again. Let's start imaging. And this again is, you know, we have to go look up what this is. What's the actual catalog number? Soul Nebula Wiki. Orion looks really bad too. It does, you're right. Wow, these are beautiful images, aren't they? Is it Westerhout 5? Westerhout 5 or Sharpless 2 199 or LBN 667. Let's go back over here and look. LBN 667. LBN, let's just say Soul Nebula, and show info on it. Yeah, IC1848 or LBN 667. Let's use IC1848. IC1848. Let's change the name here. IC18. I'm not done changing yet. IC1848. Now, ask me again. Yeah, IC1848. Okay, let's do a... Yep. Dennis agrees. And let's put this dark bar right there. Bring down the blues just a shade. It's kind of hard to color balance for some reason. Isn't it? Let's start over with our white balance. Oh, I suddenly realized why it's so hard to color balance. Because this nebula is that big. we're seeing nebula for our entire screen is filled with nebula. And if you look over here, you'll see what I mean. The entire middle of the screen is just engulfed in the nebula. And that's why it's so hard to color balance. That was hilarious. I kept thinking, why can't I get rid of these reds? And because they're there, Doug. That's a realistic picture. That's crazy. Wow, and look up here the way these reds are starting to form. So let's make the night sky a little bit blacker by pulling over here. I wonder if those blues should still come down a shade. Wow, look at all of this nebulosity right here. I don't think this could still be light pollution here, huh? let's look at where we're looking in the night sky. First of all, let's go to the 178. Yeah, see all this light pollution? I think it just wreaks havoc with our light balance. Thank you, Louisville. Thank you all your filling stations and shopping centers and billboards and bridges that are lit up with uplights. Thank you, Louisville. Now let's go to the planetarium software just briefly and back off. Kind of get a picture. Yeah. Yeah, this is all that Louisville light pollution. There's Cassiopeia. All that Louisville light pollution there. But still, the other thing we're seeing is these hues of whatever, reds and blues and stuff, aren't we? Grays and greens and man. I've tried to image this before. Look, January 4th. I guess this might be my first time to visit this target. Sure is a dim object. Exposing it 20 seconds took me 15 minutes to get something worth remembering. Lots of H alpha, beautiful even if it's dim. The Sol Nebula. That's what I said on January 4th. Oh, that was just January 4th, 22. So that's not been that long ago. Just a month. So let's try another one here. It was still difficult. We have lots of Louisville light dome in this part of the sky. Makes it tricky. Now, see, look at that. Yeah, look at that. Rainy Florida. Papa Tech, welcome. Well, Papa Tech, at least you can see us trying to color balance the Sol Nebula here. Thanks for joining us. I had written last month in an observation, Papa Tech, that this nebula was really dim, and it took me 15 minutes. We have 6 so far. Let's drive these up. I'll tell you what let's do. Here's what we're going to do. We're going to focus on this part of the sky where this nebulosity is. And just enjoy that for a second. So this is IC1848. I'm going to snap a picture using the screen shot like that. And just name it File, Save As, and put it in Desktop, Sharp Cap Captures, IC1848, 7 minutes, 2022 0205. By the way, we should start for the Messier Marathon. I changed my hardware settings so it puts my name at the end. See, Doug Lucas, we should for the night of the Messier Marathon ask people to do that. That way we can tell which picture is which. Okay, we're going to stop live stacking this and let's go down to the Heart Nebula, see if we can see it any better. So let's go back out to auto and let's go back to the Heart Nebula and say center. Wow, that's beautiful, isn't it? You know, it's a shame to lose this bright part down here, isn't it? Rats. But if we go up too much farther, right there, huh? Now, don't I have a thing that says slew to gaze? I think it's in the, whoops, right there. I think if I go Control T and say slew to gaze, then it'll put it where I'm looking. Now let's open up our info on that. Stick it over there out of the way and go back over to SharpCap and change the name to this, which is IC1805, and then start imaging. Very pink. You're talking about the Sol Nebula, huh, Papa Tech? Tough without the HA filter, if I remember. Yeah, I try to pretend that this light pollution filter lets me see hydrogen, but might be wrong, huh? Some folks might be doing their imaging with something other than SharpCap, the ASI Air. You are absolutely right. I think Jeff uses ASI Air. So anyway, people are doing their image with something else. Maybe it'll let you assign the file name with the way you want it. PuppetTech should be able to change the name in ASI Air. Good. So here we are in the Heart Nebula. And it says it's a diffuse nebula, giant clouds of dust and gas, and then it gives the normal emission reflection dark nebula. And this is diffuse nebula. So I tried this in 2021 in December. Cloud bank moved in, tried it again on the 3rd. This is the beautiful, though smallish object in my RASA 11. Why did I say small? And here I can see why I thought the target was smallish back on December 3rd. I was basically assuming that the bright core was all there was to the nebula. In reality, it's just a bright core that I was seeing. Tonight I imaged more integration, short exposures around 3 seconds each, and started seeing the whole heart around 5 minutes. Did a quick skylit live stream comparing shooting a 30-second exposure with 3 versus 3 second. I like the 30-second exposures better. Beautiful object. So this showed up better with 30 seconds that night. Here we are a month later trying 20-second images, 20-second exposures again. Haha. Still, we can make out the hydrogen. It's all this red. All this stuff. All this pinkish, brownish, red stuff. Look how that's slid there. It's odd, isn't it? Maybe because we didn't. But this is glued to the star, so we're okay here. Let's do a color balance again. Did you reset the pic? It is, you're talking about the histogram, right? Yes, it does it as a part of that little sequence I have. Let's not use quite so much blue. I think we'll see that reddish stuff. See how it's starting to come in up here? And like in our picture here, see how this is all just a big ring. But there is a core. think that this must be the core right in here. Control. Yeah, see those clouds of hydrogen there? We can go up to 100, can't we? Time to refocus, isn't it? Look at at 100 the way we're just barely starting to see stars out of focus. So we'll go focus after this target. I like using this wheel on the mouse. It's so fun. Now look how when we bring our blues down, our greens start to show up in this part of the sky. Wow, look at that. How about that? No, I think this is the heart, isn't it? Let's go look. Do you think? No, remember I said slew to gaze? I wonder if, yeah, I think when you use slew to gaze, it doesn't freeze in on a target in the planetarium software, in Starry Night Pro, when you use slew to gaze. But in SharpCap, it went there and just stayed. So I think it is the Heart Nebula, isn't it? Papa Tech says it looks like what we were looking at before. Well, let's just find out. Let's save this. And then let's stop live stacking. Let's set this back on next target. And then let's go back over here to the planetarium software and slew to maybe this. It's not quite. There's a star. We can slew to that star and get centered. Ernie, that's a good question. I see you're asking, why is the field moving with respect to the object in the planetarium software? It's because I used the command slew to gaze, and I didn't glue in on a particular target. I used slew to gaze. I think that's why. Look how now the crosshairs of the scope are down here. See, this is where the scope is. But that is strange that the scope is not. Oh, it's because we're not centering on the new target, which is this star. There we are. Let's just do that. So we should be slewed here now. Yes, we can plate solve, but we're on the target. We're there. I just have trust, Ernie. We are right smack on it. See what I mean? That's that bright core that you're seeing right here. The reason I knew that we were on it is because we've already plate solved 2 or 3 times on other targets. So we were going to be smack on it with this mount. Once you plate solve 2 or 3 times, then you can depend on it. Boy, I don't know. Maybe you guys were right. Maybe we're stuck on the soul. Because no matter what, we didn't have this bright core down here, and did we, on that last picture? So Papa Tech, you might be right. Yep. So the Heart Nebula comes out a little better, doesn't it? It shows up a little better in the pictures. And the live stacking. The bright area, Dennis says, is LDN 1359. Let's go look at that. LDN. Yep, right there. LDN 1359, exactly. Select other. Exactly as you said, LDN 1359. Well, actually, LDN 1359 is a dark nebula. So I'm not sure that would be the bright, because you know what LDN stands for? That catalog is like Lind Dark Nebula. So I don't think the dark nebula would be this bright part. I think this is LBN. And that's, is it Lind again? Bright Nebula. So I think this is LBN, Lima Bravo November 648, I think. Let's do a quick observation on this. Actually, let's just add to the one that we were on, this. However, when we restarted the live stack, we saw a better view. Maybe I hadn't slewed the scope off of the Sol Nebula, as my buddies suggested. I could have very easily forgotten. Now that we can see whatever that's called, LBN, what is it? 648. It's bright. The heart is brighter than the soul. There's probably something metaphorical about that, huh? The fish head at the bottom right. Oh, Frank. Love it. Ernie says, slew to Mel 15. That's the cluster in the center. Melot 15. Right there it is. Yeah. Yeah, you're right. Melot 15. Melot. What you can do in Starry Night Pro, if something's covering it up, you can hover over it and right click and it'll choose Melot 15 for you. That's that open cluster. Well done. Well said, Ernie. Ernie, where are you speaking from, by the way? Where do you make your observing home? Okay, let's push these mids up a little more. This is just 4 minutes. I'm impatient, aren't I? There's that fish head, as Frank affectionately called it. The fish head. So this we said was LBN 648. Let's do a new observation on that. LBN 648, diffuse nebula, giant clouds of dust and gas, emission 2 degrees wide. Wow, so they pretty much, the fish head, as Frank called it, LBN equals, let's go look and see, make sure that's Lind. I can't remember if it is or not. Let's say LBN 648, is that what it was? Wiki. Heart Nebula. So that's the whole thing, huh? Huh. Oh, Fishhead Nebula. I thought you'd made up that name, Frank. Near Buffalo. Well, you're a next door neighbor to Frank, Ernie. Frank's in Schenectady, just a hop, skip, and a jump down the road. Scott Visions, you're enjoying all our snow, Ernie? I'm not far from you, just outside Niagara Falls. Oh, that's right. You guys would be next door neighbors. Frank, wife from Lancaster. We met at Fredonia. Too cold up there for me now. Yep. We need to look up this catalog and make sure we know what this LBN stands for. What would I have to do? LBN catalog wiki. Will that get it? Yeah, Lynn's catalog of bright nebula. There you go. LBN. Also can refer to a railroad in China. It's not this. LBN. IC1848 is the cluster only. Anyway, there you have it. Let's call this a day at 7 minutes. Squeeze whatever we can out of it. That's all we're going to get at 7 minutes. I think Frank is right. The fish head is what we're going to remember. That's the memorable thing. LBN 645. I wouldn't pull your leg, Doug. LBN 645. First time catching this live. So glad you're here, Ernie. I bet you used to live in Clifton Park, Frank. Nice. Where's home now, Papa Tech? He's in Florida, like something park, is it? LBN 645. Okay, we're going to stop this live stack. We're going to go to the next target sequence. We're going to go to planetarium software, and for Dennis, we're going to try to go to LBN 645. Oh, that just slews you into the fish head. LBN 645, right? It's a little bit different, isn't it? LBN 645. What's the difference in LBN 645 and LBN 648? Central Florida. Ernie's lives south of Hamburg in farm country, about 2 degrees tonight. Won't be imagining due to broken wrist. Ouch. Man, so sorry. Won't be imaging. Both the wrist and the temp. Yep. My niece and nephew went there. Fredonia. Ernie, I ride the motorcycle out of the way. Well, it used to be before COVID. Sorry, Doug. That is the fish head. Oh. So you said LBN 645 is the fish head. Well, rats. I think that just might have... Nope, there we are. Let's settle this once and for all. LBN 645. I don't know. Dennis? I think I find a lot more about the Heart Nebula and stuff by using LBN 648, but then again, I'm just a beginner. I'm still new at all this, but I'm not finding a lot of LBN 648. Anyway, I'm sure you're right, Dennis, because I am honestly a beginner. You know what I'd like to do real quick is fix these stars. See how they're kind of out of focus? So we're going to take this camera offline in sharp gap, and we're going to close it so it's not hung onto the focuser. And we're going to go to Nina. Oh, Stellarium. LBN 645 is the very small diffuse nebula just below the fish head. So there you go. IC1795 is the fish head. What we have here is an argument. No, I'm just kidding. I'm sure it's just that we refer to it with different catalog numbers, the same thing. Okay, so there's the, and let's start our autofocus. Okay, so LBN 645. We're already centered on it. Why am I not seeing? Oh, no. Let's start over. LBN 645. Select. Oh, it's right there. Oh, so it's not imaged. Wow, did you see those nice images come in to Starry Night Pro Plus, but LBN 645 is not imaged. Your current field of view is centered on it. Huh. When we get focused, let's go back and look at it and see if we can find something. Hey, while that's focusing, I wanted to show you guys something. Yeah, our focuser is working. While this is focusing, I wanted to show you guys something. I saw a bunch of guys talking about it was an observatory. I saw an observatory talking about the Sky X. So I just decided I would just get it because I thought, you know, I don't want to be saying that I believe, you know, I've been asking this question, is Starry Night Pro Plus, could it be that Starry Night Pro Plus is the powerhouse planetarium software for amateur and professional astronomers alike? I mean, just, excuse me, look at the beauty of this. Look at the beauty of this night sky that it makes, you know? It's just gorgeous. Look at that Milky Way. So I said, you know what? I'm just going to go get the Sky X. And I'm telling you, I know I'm just one day in it. But I am not liking it that much. Yeah, you're right. I am not liking it that much. Okay, first of all, I just think the map is uglier. It's a bunch of, now that I've come to love Starry Night Pro Plus, this, no offense, if you're a SkyX professional fan, I'm not trying to offend you, but look at this. This is just, to me, this is just hard to love. I mean, you would have to be the StarX Professionals programmer to love this, I think. Or maybe you don't love to just look at the night sky and admire it, and instead you have a very mechanical view of the night sky. Because to me, this just looked like a bunch of computer-generated dots. Oh, Ernie says not a fan either. Yes, I was afraid I was just warped. The other thing I don't like is the observing list. Watch. If I want to write an observation about, let's say, something like M1, okay? So what I do is I go, see, I can do it a couple of ways. I can double click on this word add, and I can just put M1 here. And it does find it. I'll pull this out so you can see. It's like located it and everything. So that's nice. So then I right click on it and say add an observation. And I can say saw this in the Messier marathon or whatever. Then I can say update my observation. Now look, I do like the fact that it puts this little tiny icon there, a little piece of paper with a pair of binoculars in the lower right hand corner to show that I made an observation of M1. But now watch this. Let's close this. Now, I'm not sure I'll remember how to do this because it is a little bit weird. If I want to make, let's see, find. If I want to find M1, it lets me find it. But when it finds it, it automatically categorizes it as NGC 1952. Now, don't get me wrong. I don't mind the fact that it prefers the NGC number to the Messier number. But look at this. Let's suppose I want now to log this, to do an observation. Look, it says no observation. I looked for M1. It decided to substitute NGC 1952. It's kind of like patting me on the head saying, we're too scientific here to use Messier numbers. I don't mind the fact that it thinks it's more scientific to use NGC 1952. That's okay. But if it's going to do that, let me see the observation I just did. But no, if I do an observation here, it's logging it under NGC 1952, and I can say, what in the world happened to my first observation? I update it. That's an observation for NGC 1952. But my observation, which was of M1, is lost. How do I know that? Because it's here. This is where I said saw this in Messier Marathon. So you see what it did? I searched for M1. It substituted NGC 1952, and it puts the observation under NGC 1952 without being smart enough to know that evidently they're the same thing. I don't like it a bit. Meanwhile, you guys are saying, looks like Starry Night is wrong on this one. What? This cannot be. HIP's 2-Fit Sky Survey is also reporting LBN 645 is a fish head. So Frank, LDN 1359 is just below the fish head. Wow. Wonder how we fix this. Oh, surely it's not wrong. Doug, if I ever get away from ASI Air, you have me convinced to try Starry Night Pro. Woohoo! I don't get any kickbacks. I don't get any affiliate fees. I had to buy my copy of Starry Night Pro, and I bought my copy of the SkyX Professional, only to find out I don't like it. So anyway, let's close this and just realize I probably just made some enemies, but man. Anyway, we're focused. So let's get rid of the focuser connection and get rid of the camera connection and close this baby and start sharp cap. You know, if I'm not mistaken, that my wrist kind of hurts. I'm using this mouse now. I remember you guys had just joined. I cleaned my trackpad with hand sanitizer about 2 observing sessions ago, and the whole observing session it was trashed. It wouldn't work. So I ordered this mouse, and now that I'm using it, now my wrist hurts. I'm sure it's my posture. It's probably because I'm reaching out there too far. I need to change my posture, don't I? There. Is that better? ASIO is not perfect, but it's easy. There you go. Okay, let's go back. Here we are. Sign onto the camera. Let's go back to a real planetarium program. Oh, isn't that just beautiful? And what are we going to do about this 645 problem? Huh. You know, LBN 645. What is that thing called Sinbad? So, Sinbad? Not the pirate. Sinbad. How do you search? Sinbad. How do you start your search here? Basic search by identifier. LBN 648. Boy. Look at that. Sinbad went crazy, didn't it? Huh. 648 doesn't even occur on this. I thought Sinbad was supposed to be the expert. LBN 648. Heart Nebula. Heart Nebula. Boy, it's not using anything, is it? Just rename it Doug 645. IC1795 is what comes up for me. Query the Heart Nebula and you get something totally different in Sinbad. Let's go by identifier again, and let's use IC1795. IC1795, LBN 645, NGC 896, IC1795 are designation for fish head. Okay. I think Star 9 identifies LB645 correctly in the description. It just doesn't point to the right object. Okay. So, wonder why Sinbad doesn't list IC1795. the Fishhead Nebula. Look at Wikipedia. Oh my goodness, this is not Wikipedia, this is Hubble. Let's take Hubble's word for it. So, to some, the nebula looks like a head of a fish. However, this colorful cosmic portrait really features glowing gas obscuring dust clouds in IC1795, a star-forming region in the northern constellation Cassiopeia, located next to IC1805, the Heart Nebula. Oh, look at that. So is IC1795 different than IC1805? What's IC1805 nebula? That's the Heart Nebula. Look down here. Designations. Official. In Wikipedia. NGC 896, IC 1805, and SH2 190. That's the Fishhead. Heart Nebula with Fishhead Nebula on top right corner. Off with its head. Well, we beat it into submission. So let's make a decision. Let's just decide. What are we going to call this thing? Let's vote. The Heart Nebula, IC 1805. Sharpless. So let's call the Heart Nebula IC 1805. What do you guys think about that? Can we agree on that? Because that's what's here in Wikipedia. I mean, isn't Wikipedia some kind of a... What did this have? Yeah, IC 1805, the Heart Nebula. So I think IC 1795 is the Fishhead, and it's right next to IC 1805, the Heart Nebula. What do you guys think of that? That seems to be what Hubble is suggesting, if those NASA people know anything. So IC 1805, let's let that be the Heart Nebula. And IC 1795, let's let that be the Fishhead Nebula. It's official, right? Papa Tech agrees. Okay, now let's go back over here to IC 1795. Look, it points out in two different places. 34 degrees. No, it's in the same place. So IC 1795 is the Fishhead Nebula. Oh, it is pointing at it here as well. The Emission Nebula IC 1795 is here. Then we also said if IC 1795 was the Fishhead, by the way, while we're here, let's look at the info on this. The Fishhead. And let's call the Heart Nebula IC 1805. IC 1805 is going to be the official name of the Heart Nebula. Yeah. Officially the Heart Nebula. Are you guys comfortable with this? Frank concurs. +1 with Papa. Dennis says, okay. All right. Well, Hubble, you know, we're quoting Hubble, so, and Wikipedia. So we looked at the SkyX Pro, and we are focused now. So let's go back to, in our list, one other thing I wanted to do is we have some targets that we haven't yet imaged in the Messier catalog. Let's go to a couple of those real quick. Like here's Messier 87, 89, 90. Now I don't think we can do 92. It's at 1 degree. 104 is at 11 degree. It just depends on where that is. I can do 11 degree in some parts of the sky. Let's find out where this is going to go. Round and round and round she goes. Where she stops, nobody knows. And it's pointing at the building. I don't think I can do 11 degrees there. Let's try. It is rising. And my photorealistic horizon says it's right above the building. And I'm sitting in this window, by the way, right over here. So let's go look real quick at this. So let's slew there. Once again, let's go here and slew to slew there. And let's go here. That's correct, Doug. The issue is the incorrect location starry night for LBN 645 fish head. Ah, so that's what we have to fix is the LBN 645 location. Okay, I'll work on that. I'll see if I can fix that. Let's see. We're still rotating around. Let's have a look at our... Our scope cam is still catching up. It's a little bit... You know, I don't really like that. I don't like the fact that those WISE cameras can drop out like that. We spent $35 to buy this camera. And for $35, it ought to stay connected. But it doesn't. It's because Wi-Fi is too far out there. We're going to get another camera. I have another camera at home, but I don't think it's as bright for night vision. Anyway, look, there's my light. See my light in the corner of the building? Remember, every broadcast, I go over and turn off the light. See the light go off? Now, the light's back on. There you go. So that's where I'm observing now. Let's see if we can get to this baby. Oh, I think we're in the trees, aren't we? Rats. Oh no, we're on 20 seconds. Let's look at next target. Ah, there's some stars there, huh? Oh, and we're zoomed in 100%. Yes, this is going to work. This is going to work, baby. Okay, so let's run, start imaging. I can see it there. I can see it right there already. M104, the Sombrero, of course. Stargate asterism is near that too. Stargate, wow. Ernie, I didn't know there was such a thing. I watched the TV show. Glad I didn't order the WISE yet, Doug. Yeah, well, if you're closer, I think 60 feet is probably doable. I'm 200. So it's really it's a Wi-Fi thing. It's just a little small camera. And keep in mind, I do have it wrapped tonight in pipe heater tape because it freezes otherwise. Now that would be a killer for you because you got those cold temperatures. Can I close this? Yes. It does freeze, honestly. So if you got temperatures that cold, then you're right. You don't want, because once it gets, I've noticed around 17 degrees, anything below 17, it freezes. Oh my goodness, look, we got the Sombrero. And now we can zoom in because we focused. Look at this, folks. You are looking at the Sombrero galaxy at 11 degrees above the horizon. Wow, look at that. Happy day, frabjous day, Kalu Kalei. Still below the horizon for Dennis. M104 should be rising. Yep, it's up here, folks. Okay, so let's save that just because we're about out of time, aren't we? It's 1 minute till 12. So let's save this real quick. Sombrero Galaxy. And we're going to save it. Save as. And we're going to say M104 dash 2 minutes. On 2022-02-06 it is now, and I'm going to put Doug Lucas on there just so I get in the habit before Messier Marathon. We don't have to do that forever, but I think we're going to have to do that with Messier Marathon. The other thing I want to do is, before I forget, tell me what this Stargate asterism is. That sounds so exciting. If I go to Starry Night Pro and put in Stargate, nothing. Rats. What is the Stargate asterism? Oh, do you think it's this right here? Let me get rid of that horizon. Does that get rid of it? Yeah. Somewhere here? Why are you getting those red circles? What red circles? You mean that like vignetting thing? Is that what you mean, Papa Tech? I bet that's what you meant. STD. That sounds like we shouldn't permit it on this broadcast. STD 1659. STF? Artifacts on your live. Oh, I wonder if that's hot pixel. You think? What do I put here, Ernie? STF? It doesn't find it. So sorry. So sorry. What in the world? STF 1659? Are you making this up, Ernie? Asterism, Stargate. Look at that. Asterism, Stargate, STF 1659. Constellation. Oh, look. Right ascension, this. Declination, that. Stargate cluster. Oh, well, it didn't find anything Stargate-ish. But we'll just go here and help me remember, Frank, is that Control Y? I'm going to try it. Nope, it isn't. Control, what is that? Control U. Control U. And we're going to go equatorial J2000, right? And this is our right ascension. So that would be this, correct? And this is our deck. So that would be this. V L 90. Oh, LOL. I'm lost. Huh. Ah, there's M104. I see what you mean. So find M104 and then it's bam, bam, bam. Is that like the logo for Stargate? Is that what they mean? Zoom back in it. Zoom back. It was showing. Can't type. Can't type. Too late with my brain. You guys are funny. Where was M104 again? Here's M10. M104. Oh, I see. It's probably because it's too low, right? And then get rid of the horizon. Get rid of the local horizon. And then you would say it's down here somewhere. I think the people at the Guide Star April 2017 Houston Astronomical Society were more moved than I am. SharpCap annotates it. SharpCap annotates the Stargate? Zoom back in. It was showing. You're kidding. Down here? I am lost. I am totally lost. Somewhere down here, maybe? Uh-huh. Star, 3 stars, star. Triangle, 3 stars. 6 stars. 3 bright stars form a triangle. 3 inner dimmer stars that form a triangle inside the outer triangle. Ah, I see. Now I'm starting to see what it's supposed to look like. Anybody see it? It's on the right leg of your, over here. That. It was on the red line, so it must be this, right? Oh, I see. So this is the outer triangle. You got to be a Stargate fan. I mean, I did watch Stargate during the crazy pandemic. My wife and I, we actually watched every episode of every season, if you can believe it. And there are like 10 seasons of Stargate, but it was the pandemic after all. Is this it? Yes. So what I would say is, if you're saying that's it, then let's name it Hipparchus 61466. Oh, look at that. Nice. Uh-huh. Look at that. So the Cinder Stargate is Hipparchus 61466. So we're going to show info. And that's a double star, multiple star system. The center, delete log entry, these guys at SimCur. The center of the Stargate. How about that? Okay, so now that we have that, let's slew to it. Mike, Jerry. Those are the individual stars. Yep. Mike, welcome. We're in the middle of imaging the Stargate. This is a find that... Who is the guy that... Looky there. Man, it is like right there, isn't it? Wow. Snapshot. I can't believe you guys talked me into doing this. This is crazy. Stargate asterism on 2022 0206. You guys are nuts. Oh, Mike, you like Stargate SG1. The guy who played MacGyver was in SG1, and it was a little better during those days. But, you know, we watched every season. Anyway, let's remember now that HIP 61466 is the center of the Stargate. Guys, it's after midnight. You've been so good. We've gone 2 hours. I fear we should end just so we don't abuse your good nature. Man, I enjoyed this tonight. It's a lot more fun. That's an oddball rare one. Yeah. It's a lot more fun when you guys are here, honestly. Thanks to everybody. We've got so many people. Richard Dean Anderson's got to know about this. I got to send this picture to Richard Dean Anderson. Honestly, it's a lot more fun you guys here. We got quite a few on live stream. If you enjoy content like this, it would just be stellar, pun intended, if you could subscribe and click thumbs up. It doesn't cost you anything. You don't have to send any money. But what it does is it gets the channel out to other people. And tonight, I'm going on record saying, I am going to refuse ever, if ever we should get to the point that YouTube does issue some kind of payment for this, I am always going to refuse and never take any money for this. And I'll send the money like to the 501c3, the nonprofit I lead or something. I'll send it to a charity, but I will never take any money personally. I won't buy gear with it. It's going to go to nonprofit if we ever hit that. That's not why I'm hoping, but I just wish we could get the channel out and a few more people's views. I think we're at 527 or something now, subscribers. Man, if everybody would just pass it on to their buddy, thumbs up, hit the bell so you'll know when we're doing this content. It would be great. All this kind of stuff. Thank you for being a part of this. And I hope that wherever you are, that God blesses your night and that you can find Stargate asterisms for always and forever. Thanks a lot. And we'll say goodnight and God bless from Emerald Hills skies. Thanks for being here. And that's all, folks. That's all she wrote. That is it. As soon as I can get to the stop stream button.